everyone again. Thanks for having me here again. You know where I come from, who I am. I'm this guy on the internet. I'm already bothering you here. I'm burning developer hours at Magento today. It's good. This guy on the internet again. So, work for a company called Rove, yada yada, Zen framework, doctrine, yada yada. Today we talk about extremely offensive PHP. Has anybody already seen this? Only one person.
No.
Hello. Okay. What do you do on YouTube? Hats or what? That's right. Okay. So extremely defensive PHP. I'm calling it extremely defensive PHP because I am an extremist when it comes to coding. There is no middle ground. When there is something that you could consider as a good practice and it is verified that it works, use it. I became an extremist, so I don't have a bomb. I'm not going to explode here, it's alright. But I became an extremist because I have way too many projects, open source projects specifically, and every one of those projects does too much. Not to talk about the client projects. We don't even know what these do, so whatever. So, and the idea is that everyone in any open source project wants a shiny new feature. I think that Magento is like the reference point for that. Like, everyone wants a feature, everyone wants something from it. Like, why does Magento not make me coffee in the morning? So this is the feature creep, like Exhibit A. Anybody know the Lonely Island from YouTube? Yeah. So it's about aggressive practices. It's not for everyone. If you're making like a thing that is supposed to live for a week or so, feel free to ignore any advice that I'm giving you here. But Magento is hopefully going to survive a couple of years more, right? Just a couple of years, right? We're all moving to Sirius anyway, right? So these practices work for very long-lived projects. You have a very long-lived project, you have BC boundaries, in 5 years you want to upgrade something, you change this little thing, and then 20 people come and complain to you. And so that works when you apply these practices. You kind of restrict the scenario. You try to get rid of these problems. And every open source project, in my opinion, should have like this, because once you put it out there, and somebody is going to use it, somebody is going to love you for it, somebody is going to hate you for it. Somebody told me you receive a lot of hate emails. That's good. I mean, that means that at least they're using it. So, know your limits. This is not for everyone. If you do your own little project at home and nobody's using it, feel free to ignore it. But for the open source practices, for the open source, please use it. Be considerate about what you release. I mean, you already know this stuff. But just because you built it, just because you have it, you don't need to show it to everyone. I will not go into analogies here. But, okay, let's start in a bold way. You are done. I think the slide is wrong, sorry. And I don't mean you, sorry. I am done. I'm a human being. I personally have ADHD, so I'm constantly distracted. And I have very little focus. A human being has a maximum focus of 7 things at a time. So you can keep track of 7 things at a time, like 7 dots on the screen. You can, at maximum, as a superhuman, track 7 of those, unless you're a monster already. And I can probably track 2 before I freak out. So we are done. We take decisions without taking everything in the context into consideration. So we take stupid decisions. We are done. We don't see what is going to happen in the future. We don't have a lot of recognition of what happened in the past. We are currently living in the present. We take decisions on just what we see, so we are taking dumb decisions. So we are all dumb. Specifically, everyone is dumb. Everyone has a limitation there. Nobody is a genius that knows everything about the world, the universe, and everything else. Not even the flying spaghetti monster. So everyone gets it done. So those who don't admit it, those who have the best words, the greatest words, and everyone loves them, those are the dumbest. So, okay, you know about defensive driving? Does anybody here know about defensive driving? I know we're in Ukraine. I know we're in Ukraine. The joke repeats itself because I gave this talk in Brazil and it's the same. I gave it in Poland, it's the same. In Italy, it's also scary. Okay, defensive driving is driving considering that somebody else will do a mistake. So somebody will cross the road without looking at the red light. Maybe there is a turn and you're going just at the speed limit, but maybe there's a slate of ice on the floor, and then you're gonna have a problem. Little kid throwing a ball on the street or whatever. So the idea is that other people will do mistakes. It's not just you. Okay? Other people, by the way, includes yourself in 6 months and yourself 6 months ago. You are different people. Tomorrow and yesterday are different persons. Consider yourself immutable. Tomorrow it's just you plus some experience minus some stuff you forgot. So, defensive coding is kind of like defensive driving. So you have to consider that you are not the only person that is going to touch this code. You have to be aware that this code is going to be touched by other people. You have to seal it in such a way that it is very, very, very hard to misuse it. So don't design so that everyone can do whatever with it. Design it so that nobody can do anything with it besides what you decided that can be done with it. That's the point. So you are cautious about everyone's code, your code as well. Your code may as well be written by somebody else if it was written 6 months ago. I don't even remember what I wrote on Friday. I wrote code on Friday, I don't remember what it was. So you have to be cautious about your code as well. Some references, all this stuff is not new. I'm not inventing anything here. This is just a talk about ranting about open source and stuff that I collected over the years, but this stuff exists since the 70s, 80s. It was written in the past. So the first one is called Complete. This is actually from the 90s. Anybody read this already? If you haven't, I think you have a library here. Do you?
Yeah.
You probably have this there. If you don't, there is a problem. Okay? This book is a bit old, but it has some good advice. So like, for example, this book had advice such as, a function should be shorter than a full page of text. Yeah, I think I disagree with this book. It should be like maximum 5-6 lines of code. But it's getting there. The idea was that. It does like stuff like, oh, don't use byref when it's not needed, and give meaningful names. It's like really simple, stupid advices. But a lot of developers don't know about them. They don't think about it. And this book is about what can go wrong, which is kind of cool. The other book that I really like is this one. This one is a book that I read in university, and I think this affected me the most in my career. This is a manual on how to build bugs in Java. You can really read through this book and they say, I know how to break Java, all of it. So you have concurrency bugs, you have garbage collection problems, locking problems, you have null pointer exceptions coming from nowhere. This is really, really interesting to read. It's giving you a perspective of everything that can go wrong. Once you read this, you're going to look at your code and you're going to find so many more bugs just from looking at what is going on. Other things that are very well known. Poka-yoke. Anybody heard the term before? Yeah? Poka-yoke, and I hope nobody speaks Japanese here because it's probably bullshit, means avoid mistakes or foolproofing. It's an industrial design concept. So what you do is you build. Another thing that I figured out is that you can plug in a USB into this. And you figure out why does the USB not work. I had it many times. You can also do another thing if you're like really hellish. They're fixing it. I mean, now there's USB-C, so now you can break it easily, but at least it plugs in easily. And it doesn't work with the drivers, by the way, from Ubuntu. But yeah, I mean, this is not such a good Poka-yoke. But you see what the problem is. One is intuitive. There is only one way to get it in. You also hear a click. You know when it's correctly plugged in. This one is kind of, I don't know. So not such a good design. So other concepts that need to be clear. Code is reusable. I think everyone is reusing Magento code, right? Code is not reusable. You don't reuse code. Code is garbage. Once you wrote it, it's legacy. Once you implement it, it's legacy. You have your idea in your mind about how this thing should behave. Then you implement it in your favorite programming language, and it's already going to have bugs. It doesn't matter how well you wrote it. The bug may even be in the engine. And remember that it's running on top of maybe a few lines, million lines of code in the Linux kernel. So it is legacy once you wrote it and it's running somewhere. Code is crap. The best way to avoid crap is to not write code. 90% of everything is crap, by the way. That's a theorem by Theodore Sturgeon. It's about literature. I think it was about science fiction. I should really look it up because I always mention it and I never remember where it comes from. But 90% of everything is crap. And if it's not crap now, it's going to be crap later. In 5-6 years, it's going to be crap anyway. So what is reusable is the abstraction. So you think about how this system and that system are going to talk to each other. So my system allows you to talk to my system via an interface, via a definition, an abstraction. There are systems out there, telephone boxes that have been built in the 60s. I mean, I saw your metro stations. You have trains that are older than my grandmother. I mean, and they still run. That's the point. The system was designed with a clear interface. You can fix it, you can replace parts, it still works, still sticks together. Maybe you have to use some duct tape, but it still works. That's a good abstraction. Okay? So don't write crap, don't write code in the first place. If you don't need it, don't write it in the first place. That's the best way to get rid of bugs. No code means no bugs, by the way. So you code for your use case. So you have your scenario, you want to fix that. Code just for that, not for your reuse case. Don't think about it's coming nice. Implement the interface for what you have to do now, and later implement another interface for what you need to do next. Don't try to go over your boundaries. Don't try to implement further than the specification that you have right now. That prevents you from writing useless code. So, okay, this was a lot of ranting, annoyances, and stuff like that. Let's go to some good practices, some stuff that we can get rid of. We're going to assume some solid code. This seems to be fairly established practice here, at least in Magento. It seems good. And I'm going to assume some object calisthenics. Anybody heard about object calisthenics? Only one person. Okay, object calisthenics is, I'm not going to explain all of it, but it's an exercise. Calisthenics is a physical exercise. It's like yoga. You are doing some exercise to make your code better. And object calisthenics is a set of rules, very, very strict rules about how to write code, such as you cannot use primitive types. If you have a primitive type, you have to encapsulate it. So it's not an integer, it's a new user ID or new amount. And it can only be a positive amount, so you have to box types. You can't use primitive types. If you have a collection, you have to encapsulate it in a collection object. Every object can have at maximum 5 or 3 properties, can't remember. Every method can have at maximum X lines of code. Every method can have only one nesting level. 1, not 2, 1. So it starts becoming really, really hard to make this code better. But if you try this out, it's an exercise. If you strive to go in that direction, you will get with very easy to understand, very clear, very maintainable code as well. You reduce the amount of bugs by a lot. So, we can make state immutable to simplify things. That's one of the things that help a lot. Anybody here use the debugger? Xdebug, right? We all use it. Thanks to Derek, I almost never use the debugger. But when I do use the debugger, when we use the debugger, what do we look for? What are we searching?
State.
Right, state. So when is what, which thing? So you're saying, why does this variable have this value right now? That's what you're looking for. By making state immutable, you get rid of a lot of scenarios where state changes in place, and you have to figure out at which iteration or which repetition this state changes this way. So making state immutable gets rid of a lot of problems this way. So you reduce the cognitive load around time and state. There is no more discoupling, it's just state now. There is no time. It doesn't change over time. So you don't have to worry about sequence of operations, or at least in most scenarios. PSR7 is a good example of this. It's not a perfect API. It's not all immutable. but it's a good API, it's a good example. We took an interface for a data format, made an interface, made it immutable, and provided it out as an implementation to be reused in cases, in case you don't want to reuse it entirely. But if you want your own custom thing, you can use the interface, and the interface specifies that it's immutable. Sadly, the PHP language doesn't have an immutable marker. That would be really nice to have. So you say this type is an immutable type. That would be really nice to have. So what about performance? PHP is not designed for immutability, so it's going to garbage collect a lot, because you create objects and they never change, you just throw them away, and you create new objects. But in general, performance is not a problem here, because you have mostly operations that are bound to CPU and memory, and these are very, very fast compared to any input-output. So my suggestion is that you have to profile, profile, and profile again if there is a performance problem. But usually it doesn't come from this. And in general, you want to operate on anything that is bigger than O log n. So anything that is depending on the amount of data and has immutability, there you want to check if immutability is a problem. But usually it's not that. Since we go to immutability, we get rid of setters as much as possible. I think this is already established here as well. At least for services, you moved everything to constructors, which is really good, I think. So in general, the setters, they don't mean anything. So do you still have setters somewhere? Yeah, on models, on products and stuff like that?
Yeah.
Yeah, I guess.
On data.
It's really hard to get rid of them when everyone is still using them in the extensions, I guess. But the idea is that you should provide an API that says change this to that instead of saying set this. When two objects interact with each other, they don't tell each other what to be, they tell each other what to do. I don't go to you and say, you're yellow now. You're like, poof, I'm yellow. Okay, and I have a Lego figure. That doesn't work like that. So the constructor becomes the only injection point. That is pretty much clear and is very established here. But you also get rid of uninitialized properties. That's another thing that you currently have, and that should probably not be done. I heard that it's about VC boundaries, so you have constructors with optional dependencies where a parameter is nullable. That should be avoided. So an optional dependency really doesn't exist. It's either there or it's not there, and you have a lot of scenarios where when this dependency is missing, you're going to have problems. So here's an example. You have a DB connection, has a constructor, no parameters, or well, maybe the DSN or stuff like that. I'm using a setter for simplicity of the example. The logger is passed in, and then you can set the logger. And this is something that everyone did at some point in their developer career. You inject something just later at runtime when you want to enable it, and the entire class behaves differently. That's kind of terrible because, well, of course we got a problem with immutability first, but the second thing is that this logger behaves weirdly now. So optional dependencies in general do not exist. In my opinion, you should instead use a void dependency. So you use a null object pattern. So what you have is a logger here. You always expect a logger. There's no setters, no modification of the internal state. Okay? And then you create your DB connection with a fake logger. That's it. It's relatively common for loggers, and you get rid of a lot of complexity there. So we got rid of setters, we got rid of optional dependencies. Now we need to get rid of any public API that is not strictly needed. So this is especially important for code that you are going to write. Before you write a public method, think really, do I really need this? The problem is that an unnecessary method can be really simply discovered because you can do the same thing in a different way without having that method. You have a different method that already does that, use that method instead. So the problem is that a public method is pretty much like a child. Once you publish it, you're going to maintain it for the rest of your life. And I think this is really true here. You can't just say, oh yeah, we're going to delete this class. This doesn't exist in Magento right now, I guess. Because you're going to have a revolution and people are going to come here with pitchforks and what are you doing, okay? So a public method should not be removed. or should not be changed. You can't add parameters, you can't remove parameters. It's a mess if you change it. So removing methods does not mean that you should have one method with 20,000 parameters. Okay, I've seen this in the PHP core API. There is the OpenSSL functions. The OpenSSL functions have like something like 7, 8 parameters. There was an RFC to add another 5 parameters to an existing function. And it even passed. I mean, I was like going to cry over a whiskey that night. But whatever, that's their problem. It's also my problem now because we have to support that shit. But you avoid logic switch parameters. It's not if a switch parameter changes the behavior of the method. So it means instead of doing this, do that. That's not a parameter on the method. That's a different method. You call it completely different. An example here is we have a spammer. Spammer has a function spam, sends an email, a template, and an opt-out link, which is by default false. This is, yeah, it's a bad spammer. By default, it doesn't give you the opt-out link. So this should be split. So this opt-out link should be a spammer with a send illegal spam. It doesn't give you the opt-out link, and send apparently legal spam with the opt-out link. Okay, that's the idea. But now you have the behavior coded in the interface. The caller of the code knows that these things do two different things. It's not hidden in a parameter. This makes it also easier to understand things. And if this behavior has to go away, okay, because we only want to send illegal spam because we gave up on being legally compliant, we just remove the methods and find all the BCC boundaries instead of figuring out who is using that other parameter. It's much simpler. All states should be encapsulated. This means that you do not expose any state of your objects to the outside. This is pretty much from the object-oriented world, the base definition that the objects are all about encapsulation and sharing messages only between each other. It's a bit of a strict view, but it works really well. In practice, this means that you have a bank account here. The bank account, I'm going to use a setter just for the example. We're passing the last refresh time. Anybody see the bug? There is a bug here already. It's setter? Well, it is a setter. I made it for simplicity. What is the bug here?
Object passed by reference.
The object is passed by reference. This is a reference, which means that anybody can modify this last refresh. So what happens is that, what is that? No, I don't care about the reader view. We have a date time. We say bank account 1 set last refresh to the current time. Bank account 2 current time. Maybe this is the current transaction time. Okay, so you get it from the transaction. And then you have stuff like a million lines of code and different stack frames and stuff like that. Transaction is committed. And then the current time is going to be updated with the next transaction time. Ta-da! Now your bank account 1 and bank account 2 changed. This is what we call a spooky action at a distance. It's a very common bug. And there is an entire programming language designed on top of this bug. Does anybody know how it's called? It's called CSS. The entire thing is designed on top of this thing. You modify it here and it changes everything over there. That's how it works. The entire language is designed like this. I mean, that's why it feels like, you know, the Peter Griffin gif of Peter fixing elimination, whatever. Okay, so the same happens when you have, so basically what you can do is you can clone, and by cloning you dereference. Another thing that I do a lot is when I receive an array, because arrays in PHP are basically a horror story, an elaborate one, but it's a horror story. What I do is I do a JSON decode and JSON encode here. So I basically dereference and recreate by serializing and deserializing. Or you use an immutable version. If you use an immutable version, that's the simplest way. Since you move to immutable as much as possible, you try to get rid of this problem. As long as you have something defined as immutable, you're going to be fine. So make it immutable, make it maybe final, type hint against it, and you're going to be okay. This means that nobody's tampering with it, unless they use reflection, but that's their fault then. You can say it's your problem. The same happens in the constructor, by the way. So if you have a money transfer, receives a constructor argument, you have the bug here as well. This is really like oil. You know, a drop falls off and good luck cleaning it up. It's going everywhere. So you have to always clone the reference. External access, by the way, includes subclasses. This is something that is painfully clear here. You can't make your classes final now in Magento because people are extending them. And if you have protected fields, you can't make them private because subclasses were relying on them. And now you have a problem there too. So external classes of any type, including subclasses, are external systems. So you should not expose state to these external systems. So if you have a property in your class, and this property has to change, maybe it's not anymore a datetime, but it's a nullable datetime at some point in time, you're going to have a problem because the subclass did not account for the scenario where this field is nullable now. So anything that is not to be exposed to child classes and is not explicitly designed for that should not be exposed. So there is a simple solution to that. When you design a new class, just make everything private. Always consider protected only after you decided, yes, this class is designed for inheritance. Then you can consider protected, but you have to first figure out, in 5 years, will I have to modify this class? And will it be a problem? That's kind of the problem there. So, private properties by default, and the subclasses access the parent class's data via public methods. Not via private methods, not via protected methods, via public ones. Other things that a lot of people do wrong. A public method should have like a transaction. So anytime you communicate with an object, this object may do something internally, but it may also fail. It is perfectly capable of throwing an exception and say, not doing that. So anything that could cause a failure should also be rolling back internal state. And what I often see is an API like this. So we have a public function add money with a money instance. We push it to an array, and then we say mark bill paid with money with the bill and the money, and we say bill paid with money, and we store it into bills. And then somewhere in a service layer, in a command handler, in a controller for the crazy ones, you have something like this, and you have two method calls. Now, what happens if the bank account add money succeeds and the bank account mark bill paid with money fails? You got yourself a problem. Now, maybe for you it's a good one because you're getting money and you're not marking bills paid. No, you're still requesting money. But what if this is an active record object? Which, by the way, is a violation on its own, but still, what if this is an active record object? This actually goes to the database. This succeeds, this fails, everything goes crash. Okay, it's not fun. So these methods are a single interaction. This is one interaction. This is a concept that in the domain-driven world is called the aggregate object. So it's responsible for moving states. So if this throws an exception, it should be designed as a single interaction, and the object should be able to roll back itself. So what we do is we make those private, if we can, of course. And then we wrap them in a single interaction pay bill. And pay bill knows if add money and mark bill paid with money can throw exceptions because it's private API now. We know whether that can throw an exception. If an exception happens in here, we can do a try catch block and do a revert of the internal state of the object. And that's it. It's also kind of better to read. Much simpler. All right. Other things we do wrong all the time. We assume method idempotence or idempotence. Everyone pronounces it weird or different. So this is a relatively common scenario. We have a controller, we get a request from it, and we get some parameter. And then we do controller request again and get another thing. This is an obvious API, but there is no guarantee that these two calls will return the same thing. None. These two subsequent calls may return completely different things because there is no type information that can give us guarantees about immutability or memoization of this API. There is an interesting feature in Hackland. You can mark a method as memoize, and then you can do this, because the language knows that this method always returns the same thing over multiple calls. But we don't have that in PHP, so we have to design against it. So what we do is relatively simple. We cache it in a variable. So, and that gets rid of the problem. People usually do it because performance. Really, nobody cares. I mean, this is like 2 microseconds. But this is getting rid of a real bug that may happen. All right, assertions. Coming from hexagonal design, anything that comes from the outside world is poisonous, it's trying to kill you, and it's evil. Okay? Anything you give to the world is God sent, and everyone should accept it. Okay, now this is, of course, an exaggeration, but that's how it should be in your API. So anything that comes from the outside world, you assert on it and verify if the data is correct. So you enforce strict invariance. This means that if you receive a username and it's a string, you should validate it, first of all. You never just accept a string. And this happens for every layer that accepts a string and makes it a new concept. So if it is a string in the controller and it becomes a username in your API, there should be an assertion between the front end and your API. The data that you receive, upcast it to a value object, and the value object is something that you understand and you trust. You can trust this thing. It's immutable and it's consistent. You know that a username object will always be a non-empty string without UTF-8 weird characters like the null byte and other interesting stuff. And you simplify data validation, because now you just create an object like this, and this will throw an exception if it fails, and this register function just needs to use the type system of the language, and it doesn't need to validate again. You don't need to revalidate inside the register API, therefore. The same goes for return types. Don't use mixed return types. Every time you use mixed in a return type, you are basically showing the middle finger to your users. It's not really useful. You're like saying, yeah, it's your problem now. Good luck. It's dangerous to go alone. Take this mixed. Yeah, I mean, value objects again. Return value objects. A good example of this is the validation of API. I saw a very nice library recently, but there are 2 known API. Well, I'm going to take Zen Framework as the validation API to make an example. The Zen Framework API for the Zen validator is kind of terrible. So you say validator validates some object and it will return a Boolean. And then you say validator get messages if you want the messages for the last validation, so it's stateful. And then you say validator get validation messages with a translator if you want them translated. Honestly, that's a mess. That is a validator validate returns a validation result. That's much more usable. And the validation result includes the original value, the filtered value, the valid values, the invalid values, success, failure, messages, translated messages, whatever you want. Value objects again. Fluent interfaces. Anybody use Fluent interfaces? I think we all kind of do at some point. There are scenarios where Fluent interfaces are really useful because they really help readability and they're really important. A good example of this is the configuration builder in Symfony or query builders in SQL-oriented APIs. But here's the problem. So these are 3 usages of the same API. I'm not tricking you. All these 3 work fine. Okay? They are all equivalent. Does anybody see the problem with this? Or it's something we said at the beginning. The problem here is that this is not Pokayoken. You have multiple ways to shoot yourself in the foot here. Why is this better than this? This is perfectly okay. There is no need to have 3 ways to do that thing. Okay, so Pokayoken. Keep it simple. Reduce the amount of ways to shoot yourself in the foot. At least we are going to know how to treat it once you shoot yourself in the foot. There's an entire blog post for that. The other thing that I can strongly suggest, at least for new classes, you can't do that on classes that were already released because it's a BC break. Make classes final by default. You design it, you decide how it's going to be used. You don't know how it's going to be used in subclassing, therefore don't allow subclasses. Make classes final by default. If you need to use mocking, don't mock the classes, mock the interfaces. If you have value types, such as value objects, don't mock them. Use the real thing, because it's a value. It's not changing behavior. It's a definition of a value. So classes, make them final by default. It's removing a lot of problems, a series of categories of problems that are really related with how people are going to use your code later on, and make it actually much more unstable. Actually, you have to make the code more stable just to support their unstable use case scenario. That's what you're doing when you're allowing inheritance. So again, inheritance is another use case scenario. It's not your original design. It's something else that somebody is designing against, and they're trying to reuse some code. That's the 99% of the scenarios. They're trying to reuse code. They're not trying to add behavior, they're trying to reuse code. There is a simple trick to decide whether an extension is valid or not. You can extend when you take your class, remove all the method bodies, make it an interface, and then think, can I extend this interface? If I extend this interface with another interface, am I adding some semantic meaning? Is it a different thing? If yes, then it's okay to use extends. Otherwise, you're just abusing the inheritance system. Okay? So usually you don't need it. That's the trick. Think about it in interface. Does it make sense to extend this interface? Yes, no. That's what inheritance is for. Because inheritance is a definition of types and behavior, not a code reuse mechanism. It was added as a code reuse mechanism, but it causes a lot of problems because code reuse is contagious. You know, it's pretty much poisoning everything that touches each other's API. All right, traits. No traits. Okay, just one thing here. This is a bit PHP's fault as well. Traits only exist at compile time. They don't exist at runtime. The compiler puts them together and makes you an object, but at runtime these traits don't really exist. And if you try to inspect them with reflection, you get some really weird stuff as well. And also some bugs that can't be fixed in PHP anymore. So specifically in PHP, traits are really messy. Try to avoid them when possible, because they bring in a series of problems because they are actually about code reuse. Do you really need to reuse the code, or maybe did you want to use composition there? Right? And the other thing is, we keep talking about the don't repeat yourself. Copy-pasting code is okay. I said it. Copy-pasting code is okay. It's not okay to copy-paste code from Stack Overflow. But it's okay to copy-paste tested code. Copy also the code, the test, please. But the don't repeat yourself principle is not about code that is repeated. It's about concepts that are repeated. If you have a concept which is something like checkout of a shopping cart, and this concept exists 2 times in your system, okay, you are likely going at some point to have a mismatch between these two. So you update this system to do a checkout, but you forgot to add the business rule in this other system, and now you have them both out of sync. That's where you want to have the don't repeat yourself principle. Because you have 2 systems do the same thing, except that they behave differently at some point. That's the point. So you don't repeat yourself at interface level. Okay? So if you add a method to one of the 2 shopping carts, then you got a problem. Because the other one doesn't know how to do it, and maybe will use it at some point internally. Other stuff that is more practical. Ensure deep cloning. The PHP language allows you to clone anything, which is a bit of a mess. The problem is this one. So you have a login request, you clone it. If you do not clone also every private member, you get the same spooky action at the distance that we saw before. And there is no protection against this anywhere in the language. So by default, every object in PHP is vulnerable to this. I could create a user account, another user account by cloning it, modify it here and modify the private properties of the other object by just interacting with this other one. This is a mess. So this is important, clone it. This comes from the Java world. In the Java world, it's one of the first things you do when you do like the hash comparisons and all that stuff. It's very common to clone stuff. And the other thing is that cloning requires deep understanding of the encapsulated details of an object. You can, though, clone anything in PHP without having an interface for saying this is clonable. So you can clone anything. And that is a problem because this is a contradiction against the object-oriented principles. You're now allowed to do this operation on a public API that is not specified on any object. So the best idea is to maybe disable cloning where you don't want it to be cloned. Anybody try to clone a PDO instance? Okay, yeah, maybe. You throw, well, we have a human, we have a public function clone, and you throw an exception. Why would you clone me? It's currently illegal. It's gonna be illegal at some point. They're gonna make big bucks out of it. So you can do it like this, or you can define it as private. Private function clone. That's also sufficient. If you define it as private, it's gonna throw an exception as soon as you try to clone. It's gonna say call to a private method. Same for serialization. Serialization is a translation of internal state from one layer to another. And at least in PHP, it's a constant source of security issues. But from a pure API perspective, we're doing the same thing. We're looking in the internals of our objects, and we are assuming that we can serialize every component of our object. So, do you know the life cycle of every element in your object? Can you serialize a socket, push it to another server, unserialize it, and use it? I don't think so. That doesn't work. So, is your object supposed to be stored somewhere? Or maybe it's supposed to be volatile information? Some information is also security sensitive, like tokens, password hashes, and stuff like that, or even clear text passwords. You don't want an input password to be ever serialized. You want to throw an exception when somebody tries to serialize it and maybe push it somewhere in the message queue. Because that message queue may be consumed by a middleman that is actually malicious. So, same thing. No, my thing Kenneth has. So you throw an exception in the sleep method. That's actually a good example of the usage of the sleep method. Otherwise, don't use that. This is all magic voodoo shit that nobody should touch. So you can do that, or you can declare it as private. It's going to do the same thing. Serialize should only be used on things that are serializable. You designed it to be serialized. Otherwise, use a serializer and maybe define a contract between these objects. Okay, I'm almost done here. Unit testing, I'm a bit from the old school here. We're talking about branch coverage. I think that it is important to cover all the scenarios. I mean all of them. And this is going to be like bringing your CRAP score, which is a ratio between code paths and number of tests. You want to bring that below 2. Which means that if you have only one code path and one test, the ratio will be 1. If you have 3 code paths and 2 tests, it's going to be 1.5. So it's kind of acceptable. If you try to test WordPress, you're going to be finished in, well, maybe the life of the universe. There are some methods like in the Symfony YAML parser, and it's a parser, which means that it's horrible by design because it needs to be fast, which are absolutely impossible to bring below this score. So this will make you really cry, and you will hope to have less features, and it will be amazing when somebody will tell you, oh yeah, this object doesn't need to support that. Let's take an example. We have an authentication service, returns a boolean, throws some exceptions, authenticate with some credentials. Okay, so that's the API. And then we have myLogin. This is the class that we want to test. In myLogin uses the authentication service. It receives a username and password. And by the way, these slides were written pre-PHP 7, so sorry about that. So you authenticate with some basic credentials, so you build the basic credentials here and return true and return false. How many tests are needed here? 2. More. You need Yeah, 6, kind of there, yeah. It's 5 tests by default, so you have 2 paths. These are path 1, return true, and path 2, return false. Then there is every path for these exceptions, because these exceptions are thrown by the interface, and you need to verify that these exceptions bubble up and they're not caught in your code. And this is just because they're in the interface, so they're checked exceptions. And then you may have other failures here, because we have static coupling of basic credentials with our code. This basic credentials is a value object. It's usually not important to test that, but this may fail if the username and the password are incorrect. So true, false, exception, 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 5 tests, and there's also the value object. Let's recap. All of these are suggestions. If you hate this and you say, what is this guy talking about and why can't I just go back to my afternoon nap? Then feel free to ignore them. But please do use them if you plan to publish your own packages. And if you're planning to release new features in Magento, consider applying them. It's a good idea to start thinking forward, as in, if I release it now, how likely is it that people will completely destroy it? That's the idea. It's a battlefield, okay? You have to plan strategically. You don't trust anybody's code. Nobody's code. This includes yourself. And you try to reduce features to the minimum. If it is not in the specification, don't implement code for it. Don't go the next step. If it is not within the stuff that you support and use internally as well, don't code for it. Because this means that nobody is using it, and somebody else will use it and find a bug that you don't even know how to fix because you're not even using it. That's the case for Doctrine. I maintain Doctrine. I don't currently use it, so yeah. I don't even know when bugs come in, what they do. You ain't gonna need it. That's basically the idea. Enforce strict invariance on stuff that comes in, and just send out value object on the outside. So await strict and return strict data. Don't return mixed. That's relatively simple. Don't return mixed. And that's it pretty much. Thank you.